UVA photographers. So I've invited our VP Tom to tell us about what we're looking at here.
Hi, I'm Tom. This is a shot that Prasad took about 2 weeks ago, I guess now, or so, 10 days. And this is a hydrogen alpha view of the sun. If you had a solar scope, this is what you'd see, but this is actually an inverted image. So he took an image of the sun, a hydrogen alpha, but inverted it to bring out, you get a little more contrast when you do that. And what you have here is you still see the filaments. I don't know if he made a composite image here of the filaments and then just inverted the disk, or if the whole thing is inverted, but the prominences look pretty much normal. But when you get a prominence on the surface, it forms a filament. Now, normally, if you're looking through an H alpha scope, this would be dark. But here it shows more of a three-dimensional when you invert it. That's why people do it a lot. These real dark areas here are actually flaring areas that actually appear quite bright in hydrogen alpha, almost white if it's a really big flare. And sunspots like the one right there appear white because they're inverted. And there's one over here, white one, right about there. Hard to do this, but that would be a sunspot. But this is gives you an idea of what you could see, though. At least if you have inverted imagination here, what you would see with a hydrogen alpha scope. And it's been very active. And actually, there was a huge sunspot group, 3355, I think they numbered it. 44. 3344. No, it just went off. Okay. But there's a large group just went off. It was naked eye. You can see it naked eye. You can see with the smoke. When the smoke rolled in, you could see it. But that gives you a lot of opportunity for people who have a white light filter as well. You don't need a hydrogen alpha filter. You can get just a white light filter and see some phenomenal things. And the air has been quite steady. I've been out the last few days, and I was out yesterday, and it was the steadiest air I've seen on the sun for probably 3-4 years. It was unbelievable. It was just rock steady. So anyway, go out and enjoy it. It's supposed to hit peak in about a year, but they're saying it's kind of ahead of schedule, so it might be the max cycle maybe in a month or two, might actually peak before it starts declining again. But we're in good shape for the next year. So if you have a scope or you think about buying a white light filter, now's the time, because this is when all the early action's happening.
Okay, thanks, Tom.
Jeremy, I'm not getting this to advance. Am I not doing here? That one. Okay. This is not anything.
Ah, got it. Thank you. Here's another photo that Prasad took, and he was sure this looked like a dog's face. Can you all see it? I think it's really interesting. All right, now to the mundane, upcoming events. So the first item on our list is solar viewing for kids at July 12th at the North Wales Library. There's no more room in this program for the kids, but there's room for people to bring their scopes for the kids to view. If you'd like to join Barry Johnson and I at the North Wales Library, you'd be welcome. Also, we have our Valley Forge Star Party on the July 22nd. And with a rain date of the 23rd. We have the Temple Ambler Star Party, which was rescheduled from last month on July 24th. And the Chestmont Star Fest, which is an all-day event for families and kids, and that's a lot of fun, and that's on the 19th of August. We also have a bunch of overnight star parties. We especially wanted to highlight Cellophane this year, which is having a 100-year celebration that Tom, you want to tell us about that?
Yeah,
Could you come up here? They won't be able to see you. Sorry. Should have kept you up here.
Stellafane is the name of the pink clubhouse they have up on this hill in Vermont. And it was built in 1923, and it's the 100-year anniversary of it. And they're asking anybody who has entered a telescope at Stellafane to bring it up and exhibit it this year on the hill. So there should be, besides the usual collection of homemade telescopes, which can vary between as little as 10 or 12 to maybe 30. There'll probably be a very large number up there on the hill. So it's a particularly good year to visit Stellafane. There's going to have some other special activities I hear as well, but they haven't published those yet. But if you ever thought about going to Stellafane, it's a big star party. It covers a lot of ground, a lot of acres. It's in several sections. A couple thousand people usually show up, sometimes a little more. People are very avid amateur astronomers and telescope builders. It's a lot of fun. So if you haven't been there, this might be a very good year to give it a try. But so it's kind of a unique place. It's more than just a star party. There's lots of talks constantly during the day. So anyway.
Thanks. How many people have been to Stellafane? Show of hands. Okay, this is who you should talk to if you'd like to know what to expect when you get there. And also, I know many of you were not able to get to the Cherry Springs Star Party, and because it was sold out 3 months in advance. Well, the Black Forest Star Party, last time I checked, had not yet started their reservations, but so that's another opportunity to go to a star party at Cherry Springs State Park. And the York County State Park or Star Party is a nice local party, pretty small, low key, lots of fun. There's also a longer list of star parties that are for overnight, and for those you can check the newsletter. Jeremy put together a nice long list of all the regional star parties, so check it out. So also, I hope you paid a visit to Ken. Ken, you want to wave? Say hello. Ken's doing the raffle tonight, the GDA quarterly raffle. He's got lots of good stuff out there. Tickets are 3 for $1. And if your ticket gets picked, you get to go and pick whatever item you want from the table. And also, just a reminder that if you have lower value items that you'd like to donate to the raffle, you can bring them in at any meeting, and then we'll hold them until it's time for the raffle on a quarterly basis. We have 2 new members this month, and they are the students that presented their work last meetings. Elise Olmsted and Iftikhar Toronto. So thanks again. Thanks for giving us such a great presentation last month. I heard it was great. Yeah. So they won honorary memberships to DVAA for a year because of as part of their prize. Okay, our committee reports are next, and I just wanted to thank John for this wonderful image of the M16 Eagle Nebula. Yeah, there's John back there. He does a great job. Okay, first I'll ask Joe for our rentals to give us a short report.
Tonight, we brought the DVAA rental tracker, and it's the first generation tracker. It's a great little instrument, being as it's looking this season right now. We're going away at containers or wherever we're starting. You have a DSLR camera and perhaps an intervalometer. You can take this and do some great shots. It's a Milky Way. And there are some videos online. I alluded to them in this little informational handout. right here. So if you're interested in it, just let me know. I'm here. All on. So thank you.
All the week.
Oh, all night.
Thanks, Sharon. Ken, could you come up and tell us about what's happening at Wallops?
Just wanted to put a plug in for Wallops Island Flight Facility, not too far from here, 3.5 hours south or so, right on the eastern shore of Maryland and Virginia. I work part-time as a volunteer there, in addition to being part of this club. We're having a launch, probably the last launch for several years, to the space station, to the ISS, August 1st, scheduled for 8:30 p.m. That's a window of about an hour. If it goes that night, it'll be August 1st. If not, probably the next night on that following August 2nd. Anyway, it's not far down there. I'll be there. So I'll say hello if you're there. By the way, the visitor center at Wallops is free. Can't beat that. How many of you have been to the visitor center? Should see a lot more people there. This is the only other NASA facility that we can get to without going to Florida. So it's a great facility. This was established in 1945. I got interested in I just tell you a little story. My father designed the metals that were used in the Gemini missions. Those capsules were first tested at Wallops, and they actually have the rocket that tested those in outside the visitor center there. So it's kind of a really interesting place. A lot of the unmanned missions have first been tested at Wallops, believe it or not down in Florida. So
You may want to mention the last launch from there.
okay, yeah, it's the last launch from there for quite a while because Northrop Grumman is the contractor that runs the ISS resupply missions. And they subcontracted out the engines for the Antares rockets to resupply the space station with a company in Ukraine. And we know we have a little bit of a problem in Ukraine right now. We have one last set of engines here. So it'll be it for a while. SpaceX will be doing the resupply missions from the next couple of years. They're trying to redesign the Antares rockets right now so that another manufacturer will make the engines. But another neat thing to see down there is there's a company called Rocket Lab, which is the major competitor for SpaceX. It's out of New Zealand. They're now launching from Wallops. So if you plan it right, you might be able to see a Rocket Lab launch.
Thanks. Do we have any other committee reports tonight? Okay. I did want to announce also that we have acquired enough telescopes that have been donated that it's time to have an auction. It's been 3 years since our last auction. And what we usually do is we wait until we have a good cadre of stuff. There's a lot of good stuff in the locker. You might not know, but we have a storage locker in King of Prussia where we store things that are donated. So the reason I'm telling you now is that we'd like you to check through your closets, and if there's anything that you're not using anymore that you'd like to donate and include in the auction, you can bring it into this meeting and we'll put it into the auction. But put that on your calendar, November 17th, I think. Yes. Our monthly meeting in November, we'll have the auction. Oops. Okay, I walked too close. I got feedback. Okay.
Reactivate the screen.
Okay, thank you. All right, I think I can invite Al up for this next item. Al Lamperti.
But the Astronomical League has a number of observing programs. One of them is the Caldwell Observing Program. And
force field and reactivate the screen.
I just hit the enter button.
No, move the mouse, move the other mouse. The other mouse, move it just for a second.
Oh. Here we go. So Patrick Moore made a list of very pretty and very large objects that were not Messier objects. And about a little over 100 of them. Some of them are in the southern hemisphere, a little beyond what we can see from up here. But one can observe 70 objects or 109 if you have the ability to go into the southern hemisphere. You can also do imaging on this program as well as many others. And I'll talk about that at the August meeting. So we do have, whoops. Oh, okay. So I'd like to present a certificate to Jan Rush, who observed at least 70 of these Caldwell objects. And she received a certificate and a pin with the cat side nebula on it. So Jan? I was asked how long it took you. When did you start?
2.5 years.
2.5
It
years.
was hard. It was really hard. And I have to stop at 70 because my scope has reached its limit.
Use
Yes.
neutrinos.
Huh?
Use neutrinos. They've now mapped out the Milky Way in neutrinos. No excuses.
Thank you, Al.
Sounds like the very definition of it.
So now I'd like to introduce our program chair, Jeremy Carlo, for the observing report.
All right, thanks, Janet. Are there any other committees after me? No. All right, so it'll be me and then it'll be Ray. All right, so let's see. So tonight I'm doing the observing talk. I'm introducing the speaker and the AV stuff. So triple pay for tonight.
They'll double it.
3 times 0. All right. That's the big money right there. All right, let me
Maybe it better. Did you switch it on?
now I did. I think the volume needs to go up a bit. I think that should do it. Or maybe we need to do this one. That better?
Yeah.
All right. Here we go.
Less hiss.
So tonight, we're going to do the July 2023 observing report. So I think this slide pretty much duplicates what Jan already talked about. One thing to add is that the new moon this month is on July 17th. So if you want to find out about dark sky observing, go to groups.io. It's DVAA@groups.io. You sign up for that. I think you do have to be a club member in order to sign up for it. But once you're on that, any planning about who's going to Green Lane, who's going to Blue Mountain, who's going to Cherry Springs or wherever, that's where you'll find out about that. Because obviously between the clouds, the rain, the smoke, and all the other stuff we do in our lives, usually you have to plan these trips at the last minute to get clear weather. So that's where you'll find that. All right. So some astro events coming up. July 9th, which is coming up real soon, Venus actually reaches its greatest brightness. Now you might be wondering what's happening there. So Venus is currently on the inside track. It's getting ready to pass between the Earth and the Sun. So it's coming towards us, which means that it's getting bigger as we see it in a telescope, but it's also getting closer to being between us and the Sun, which means it's becoming a crescent. So the disk is getting bigger, but it's less illuminated. So those two things are kind of playing against one another. It turns out that Venus is at its maximum brightness when it's kind of a thin crescent, getting kind of low in the evening sky or low in the morning sky. So it's going to reach its greatest brightness in just another couple of days. And it's going to continue falling lower and lower in the evening sky. And then eventually will reappear in the morning sky. There'll be a couple of conjunctions in the days after that. And July 17th will be the new moon. So plan on the dark sky window being like July 10 to 20, something like that. So that's if you're planning any observing trips, that's probably when to do it. Couple more conjunctions. Then, of course, on July 22nd, everybody's favorite planet or former planet or whatever, Pluto will be at opposition. Then the moon starts going through its phases. There is a conjunction of Venus and Mercury. There's a little meteor shower. Mercury reaches its greatest eastern elongation on August 10th. This, because of the angle of the ecliptic, is actually one of the least favorable apparitions of Mercury for the year. So unless you got a really, really good horizon, don't bother. Generally, sort of May and November are about the best for evening apparitions. Quick way to remember, eastern elongation, remember E is evening. And if it's a western elongation, you flip the W upside down and that's morning. So western is morning, eastern is evening. So greatest eastern elongation. And if you miss that, there's another one in 4 months. Then, of course, the Perseid meteor shower. And then by the end of August, Saturn will reach opposition. Jupiter will follow 2-3 months after that. All right, so looking west in the evening sky, you can see Venus is going to be the brightest object. Mars is getting dimmer, but still red up to the upper left. And toward the end of the month, Mercury will start to appear there if you got a really, really good horizon. And then in the few days after the new moon, it's going to slip by all of those. So maybe you can use the moon to find Mercury if you're looking around the 19th or the 20th. All right, looking toward the east, this is what the evening sky looks like. It's actually kind of hard to see on here. It's a little bit high resolution. But the thing that's going to dominate the sky, sort of toward the east in the summer, more high overhead as it gets later on, and then heading toward the west, well into the fall, are these 3 stars here known as the summer triangle. So down here, you're getting into your fall constellations. You got Great Square of Pegasus. Now we can see. This is why dark skies are important. Light pollution is bad. To follow up on what Steve said last month. So here is the summer triangle. So the summer triangle is an asterism, and an asterism very simply is any grouping of stars which is not a constellation. So if it's not in one of the classical 88 constellations, which we're going to hear a lot more about in just a little bit, then we call it an asterism. So it's 3 bright stars: Vega, which is the brightest star in the constellation Lyra; Deneb, which is the brightest star in the constellation Cygnus; and Altair, which is the brightest star in the constellation Aquila. These are 3 rather prominent constellations. Lyra is pretty small, but it has a very, very distinctive shape. That little parallelogram right there is the giveaway. Cygnus is a bigger constellation. A lot of us know it as the Northern Cross because it has that cross shape to it. And Aquila is the eagle, so you can kind of see the wings here. Altair is toward the head, so that's Altair right there, and then the tail is down at the bottom there. Let me get this opening out of the way here. So if we were in a really dark sky, this is what the summer triangle would look like. Of course, the Milky Way runs right along there. And now the Northern Cross of Cygnus, the main axis runs that way. So if you're in a dark place and you're wondering, is that the Milky Way or is it a cloud? Look for Cygnus. Find the main axis of it. If that bright thing is aligned with the main axis, that's probably the Milky Way. And if it stays there for a while. So we can see Cygnus kind of runs along here. There's Vega, there's Altair. Of course, around here, of course, if you avoid the clouds, if you avoid the rain, if you avoid the hail, if you avoid the smoke, if you avoid everything else that's been thrown at us, this is more likely what you'll see. So all the constellations have kind of faded away. I mean, maybe you can make out the parallelogram of Lyra there. You can sort of make out the Northern Cross. Maybe a little bit of Aquila over there, but what really stands out are the 3 bright stars, hence the summer triangle. All right, so let's do a little exercise. Let's say we're trying to put together an observing list. We go onto Google and I look up what are the best objects to observe in blank. And I look up the 3 constellations, and you're going to get a bunch of objects. And actually what I've given you here, this is like a couple of months of observing. You can go through all of these objects, and in fact, you'll come back to them time and again. All right, so Lyra, the headliner there is going to be the Ring Nebula M57, probably one of the first deep sky objects most of us have seen in a telescope. M57, M13, maybe M31. There's your Ring Nebula. Some double stars, probably the most interesting one is Epsilon Lyra, which is the double-double. There is another Messier object, that's the globular cluster M56. That's one of the, check it off and move on. Kind of a dimmy, not too spectacular. Aquila, surprisingly, no Messier objects at all. There are some double stars, one a little bit notable there. Some dimmer objects. There's a lot of nice NGC planetaries and clusters. So if you got a bigger scope, there's a lot of stuff in Aquila, but you may be disappointed with a smaller scope, not too much to see. All right, Cygnus, you're going to hit the mother lode because that is in the Milky Way, runs right down the center. There are two Messier open clusters, bunch of NGC open clusters, a bunch of double stars. Probably the most notable is Alberio, which is a color contrasting double. So to put it this way, those of us who've been around the block a few times, thinking of the first thing you saw in the telescope that wasn't in the solar system, not the moon, not a planet, probably Alberio might have been one of the first things you saw. And you come back to it quite a bit. So very nice object to look at. All right, nebulae, you've got the Veil, you've got the North America Nebula, both big nebulas. North America is primarily a photographic object. The Veil you can look at any way you want. Great in little scopes, great in big scopes, great photographically. The one thing you need for both of these is dark skies. Light pollution bad. Some fairly nice NGC planetary nebulas. That's Cygnus. So you got a lot of observing right here. But if you just did this exercise, there's a whole bunch of objects right in this area of the sky that you completely missed. And you completely missed them because they are in other constellations. So I'll call this the lesser constellations of the summer triangle. These are the ones that you might just skip right over, but there's a lot of interesting stuff in them. And I've highlighted 5 of them here. They are Vulpecula the fox, Scutum the shield, Sagitta the arrow, Equuleus the little horse, and Delphinus the dolphin. So let's see, they're all small constellations. They're all kind of cursed without any bright stars, which is why they don't appear in the big star charts as, oh, go look for this. So let's see, they are all small, but the differences kind of fall apart from there. Delphinus is one of the rarest constellations. It actually looks like what it's supposed to be. It's actually a little dolphin jumping through the sky. Sagitta also looks like what it's supposed to be, although admittedly that's a much lower bar to clear. It's an arrow. It has a head, it has a tail, and it's in a straight line. Scutum, I could believe that that's a shield, also kind of a low bar. But Scutum, it turns out, is in a very, very star-rich area of the sky, so it's difficult to pick that out. On the other hand, Vulpecula and Equuleus, whether they drank it or whether they smoked it, they had some good stuff back then. If they saw a fox and a horse in that. So as far as finding them, for the first 2, you start from Alberio, head down towards Altair. That'll put you right through Vulpecula and then through Sagitta. If you head from Altair, sort of in the direction of the Great Square, you'll pass through Delphinus, and then Equuleus, you'll kind of skip right over it. It's just the area where there's nothing between Delphinus and Enif over there. That's Equuleus. And then Scutum, if you look at Aquila, there's kind of a little hook at the end. That's the tail of the eagle. That's Scutum right there. All right, so let's repeat the Google exercise. What are the best objects in these constellations? What did we miss the first time around? So in Scutum, you've got M11, which I would say is the best open cluster in the sky, certainly for a telescope. It's kind of the M13 of open clusters, if you want to put it that way, but often overlooked. There's also M26, kind of one of those check it off on the list. The number of globulars, probably the nicest one is NGC 6712, and my notes on that are pretty nice for an NGC. Actually, a little nicer than a lot of the Messiers, I would say. So it's cursed with an NGC, but it's actually pretty good. And then there's the Scutum star cloud. It's a really, really rich star area. If you're in a dark place, you'll see this with the naked eye. You can see it with binoculars. You kind of see the Milky Way running down, and there's kind of like a blob that hangs off the side. That's the Scutum star cloud, and M11 is right in it. All right, Sagitta has one prominent globular cluster, M71, which is a pretty nice one. A couple of dimmer planetaries and some multiple stars. A little interesting comparison between M11 and M71. M11 is very, very dense as far as open clusters go. M71 is very, very loose as far as globulars go. So physically, these are very, very different objects. They're as different as you can get. Open clusters are young stars that formed fairly recently, like last few million years, that's recent. by astronomical standards, and they're within the plane of the galaxy, typically young stars, hot stars, blue stars, moving together through space. A globular cluster is some of the oldest stars in the universe, and they're on the outskirts of the galaxy, kind of above and below the galactic plane. Physically very different objects, but it's kind of interesting to compare those two and see if you can tell the difference between them, because they're actually quite similar. This, I would say, is the most globular open cluster you can find, and that's one of the more open globulars you can find. All right, moving on to Vulpecula. Another really nice planetary, the dumbbell, maybe a little bit overlooked in favor of the ring. Easiest way to find M27, take the Northern Cross, square off the bottom corner. Trick I learned from Ron Leonard in New York City back in the 1980s. That's how you find it. Take the Northern Cross, square off the bottom of the cross. That puts you right in downtown Vulpecula, right on top of M27. Bigger and brighter than the ring, so very easy to find. Number of open clusters, probably the most famous is Colander 399, also the only Colander object that I know of. I'm sure there's more, but that's probably the only one I've ever looked at or known by that name. That's called the coat hanger. That's what it looks like. To find the coat hanger, you start from Alberio, start heading down toward Altair, maybe about a third of the way, halfway down. Use binoculars, wide field scope, because this is about 1 degree to 1.5 degrees across. Big cluster. That's a nice one. Delphinus has a couple of double stars, fairly nice planetary. I would call that a dimmer version of the ring. So if you thought the ring was too bright for you, go for that one. A couple of little globulars, and also just look at the constellation itself. Obviously, the lines don't appear in the sky, but the stars do. Then we get to the last one, LVAAS. As far as I can tell, there's nothing worth looking at in LVAAS, down to like 14th or 15th magnitude. A couple of double stars, but that's about it. It just barely misses getting M15, which is probably the nicest globular in the fall sky, but it's just across the border in Pegasus, the big horse. So just missed it. All right, so a couple take-home points. Make sure you check out these 5 constellations if you haven't already. So if you've been sticking to Lyra and Cygnus, you might want to bring in Vulpecula and Sagitta and Delphinus and Scutum as well. You might want to check out Venus as it gets to be more and more of a crescent. Gets to the point that even in binoculars, you can see the crescent shape. Maybe get a little look at Mars. Red dot is about all you're going to see because it's pretty much on the opposite side of the sun now. Maybe even Mercury if you've got really nice horizons. And if you time it right, maybe some conjunctions. If you stay up late, you got Saturn. Even later, you'll have Jupiter. And if you're truly a diehard, you can go for Pluto. Or just wait until fall and then Jupiter and Saturn will be up at more reasonable times. And finally, if you're interested in dark skies, sign up with DVAA at groups.io. Get on that and you'll get all the emails. Thank you.
Definitely.
Yeah, I think this works better.
Yeah.
All right, so now we're ready for our main presentation of the evening. Let's close this one down and let's bring up this one here. So it gives me great pleasure to introduce Ray Harris. So let's see, he actually wrote a really great biography, so I'm just going to read it here. Ray Harris is the son of a career naval officer. Ray grew up mostly near naval facilities in Virginia and California, attending 10 schools before graduating high school on the naval base in Guantanamo Bay, Cuba. If you want to know someone who's been to Guantanamo. He attended Yale University and upon graduation spent 5 years in the Navy supervising reactor operations on a nuclear submarine. He left the service for a career in civilian nuclear power. He joined PPL in Allentown in 1980 as staff supporting the Susquehanna nuclear power plants in Berwick. He later moved into PPL corporate IT before retiring in 2009. All right, now we get to the astronomy. In 1984, Ray bought a C8. He joined the Lehigh Valley Amateur Astronomical Society in 1985 and began exploring and photographing the night sky back before the digital imaging age. All right, that was where photography was serious, where you had to do the film and you sat there auto guiding for 2 hours and you didn't even know if it came out until the next day when you developed the film. So that was when men were men. What do they say? Men of iron and ships of steel. or men of steel and ships of wood, or yeah, that was it. All right. Yeah, wooden ships and iron men. His photo of the Horsehead Nebula appeared in the January 1990 issue of Sky and Telescope. In 1987, he purchased a pair of celestial charts published in 1741. He discovered a couple of deep sky objects on these charts, and for the past 36 years, Ray has been researching and collecting early celestial charts and atlases. Ray's article, The First Deep Sky Atlas, appeared in the January 2022 issue of Sky and Telescope, and his article, The Constellations of Petrus Plancius, look at that, appeared in the February 2023 issue. Ray resides in Macungie, PA with his wife, who does not share his interest in astronomy, but who does share his love of early celestial charts as works of art. He welcomes visitors who would like to examine these works up close and personal. I've attached a recent photo if you need, well, we don't need that anymore because Ray's here in person. Second here. While Ray's getting set up, I'll give a quick update on some upcoming programs. Next month, we actually have a double header. So on August 4th, we're going to have our past president, Harold Goldner. So he's going to be talking about astronomy in the time of Shakespeare. So that's going to be kind of interesting, and also on this historical track. Then on August 25th, we're going to have an outdoor meeting at Fort Washington State Park. That's going to be an astronomy fair. So we've done that the last few years. And I'm actually still looking for a few more presenters. So if there's something that you'd like to give a little presentation on or set up a poster, send me an email and we can discuss that. Then in September, September 22nd, we're going to have John Conrad, who's one of our returning champions. And he's going to be here to tell us about the OSIRIS-REx mission, which is scheduled to do a sample return, landing on Earth on September 24th, so 2 days later. October is still up in the air. We're trying to figure that out. And November, as of like 20 minutes ago, we found that will be the DVAA auction. So that's what we've got coming up for the next couple of months. And with that, I'll pass it over to Ray Harris.
Thank you very much. Hey, it's great to be here. The only problem I have is Jeremy is a really interesting speaker and he's a tough act to follow. So I'll do my best. Can everybody hear me okay?
Yeah.
So we're going to learn about the history of celestial cartography, the mapping of the heavens. He talked a little bit about the constellations and stuff. We'll see a lot of constellations, but I have another talk, which I might come down and give you next year sometime, that talks about lost constellations. It starts with the 48 of Ptolemy and tells you how we got to our current 88 and all the ones we lost along the way. But we're not going to go into that much detail on the constellations tonight. So why study celestial cartography? The old celestial charts are just beautiful. There's so many that are so artistic. This particular one from an atlas published in 1660, that atlas, if you wanted to buy a copy, there's a copy for sale right now for $345,000. They're very sought after, this particular atlas. Unfortunately, this atlas is not scientifically important. So we'll get to what is. So today we enjoy a wonderful access to star charts to help us with our search of the heavens. We have printed ones. You can go onto a computer and set your criteria and just about focus on anything you want and then print out what you want. It wasn't always so easy. The earliest charts, this is just something from the early printing time in the late 1400s. And it's really not a star chart, but it shows the zodiac showing how the seasons change. So it's really not a star chart, and there's nothing scientific in it other than the order of the zodiac. In 1482, a work called Poeticon Astronomicon was published, and it described the 48 constellations of Ptolemy, and it provided drawings of those constellations. Unfortunately, the drawings were not scientifically accurate. The star positions bear nothing close in reality. And it was really more about the text and the description of the constellation lore about the gods of the past. So here we have Perseus with Medusa's head. Again, the stars bear no relationship to the sky. The first effort to accurately map the heavens was done by a guy named Albrecht Dürer, who was a famous artist. And he produced the first pair of star charts, planispheres, which we call planispheres something that show half the sky. And he had a northern and a southern one. And you can see in this early chart, which only has the constellations of Ptolemy, that there are big gap areas where there's no constellations, especially around the southern pole. This was fertile ground for later cartographers to invent new constellations, and they did. And they filled in all the areas, so much so that around 1801, an atlas was published with 109 constellations. We had to pare it down. In 1534, a gentleman named Caspar Volper published an update to the Poetica Astronomicon showing all 50 constellations, but this time he actually showed them with accurate stars. So this is a book about the constellations with a lot of text and a few images. The 48 constellations were shown in 40 diagrams, because some were shown together. And you can see that he really copied Albrecht Dürer's images pretty closely. So he didn't invent anything other than taking what Albrecht Dürer did and blowing it up and making it a little more accurate. But the first real celestial atlas, well, let me go back here. So we can compare the 1482 and the 1534 version of Andromeda with one that shows accurate stars, Perseus with one that shows accurate stars, Taurus with one that shows accurate stars. And then we get to 1532, where the first chart with equatorial coordinates was published. Excuse me, not equatorial coordinates. The first geocentric chart of the heavens was published. The previous one by Albrecht Dürer was what we call external view. If you think of looking up at the sky and how the constellations form, and if you look down at a celestial globe, you'll notice everything's reversed. Well, a lot of charts that were made use that external view as opposed to geocentric. So Albrecht Dürer's were external. These were the first that were Earth-centered, geocentric, giving you a view of the heavens as we actually see the stars. Same constellations, the 48 of Ptolemy. Whoops. Here we go. Oh, here. I was just going to show you the comparison between Albrecht Dürer's Ursa Major over here and Caspar Volper's over here. In 1540, we get the first actual star atlas. It was interesting in that it showed the scale of each constellation, but it did not have a coordinate system and it didn't show any constellation figures. And so you really can't easily place these in the sky. Something like this one, which I'm sure everyone will recognize as Orion, is pretty easy to figure out. And so you could find it in the sky. But I think I might challenge you to find this one. Just so happens to be Canis Minor. Now, we talked about Eculeus. Eculeus is so faint that he skipped it in this atlas. He only has 47 charts. So it's so uninteresting, he didn't bother to make a chart for it because it wouldn't have had any stars on it. In 1588, we get the next advance. Up until now, we're using woodcuts. Everything you've seen has been printed from carved wood. And that has its limitations. But this still was a significant advance, Gallucci's Atlas of 1588. So here we see Ursa Major, and you can tell it's got a coordinate system, and they've shown the constellation figure. You can tell where this is in the heavens based on the coordinate system. And the stars are a little better plotted with more of them than in previous editions of anything. In addition, Gallucci included 7 nebulae which had been described by Ptolemy. So we have here Coma Berenices, and we have here in Perseus the double cluster. And here we have in Cancer, which was frequently shown as a lobster rather than a crab, we have Persephone. And here in Scorpio, we have M7 misplotted. There's actually a star in that position. M7's down here. And because everybody just copied everybody else, it took about another 100 years before that got plotted correctly. Here we see M7 misplotted. It would really be down here. There were others that Ptolemy listed that we don't consider deep sky objects and were really just close associations of a few stars. One here in the nose of Sagittarius and one in the neck of Orion, not the sword. So you can compare Ursa Major, Caspar Vogel's efforts in 1534, Gallucci's, Piccolomini's Atlas of 1540, the first celestial atlas, and the next celestial atlas. And you can see that we're advancing. These are all woodcuts, but we are advancing a little bit in the science. The next big leap, though, was in 1603 with the introduction of engraved copper plates. And you can see a big difference there with the engraved copper plate. Bayer's Atlas of 1603 still predates the telescope, so we're still relying on observations of the stars with just the eye. But he relied instead of on Ptolemy's the Bible of celestial information. He relied on Tycho Brahe's much more accurate observations. So we have very good gradations of stars, and we have a much better coordinate system and more stars showing. So Uranometry was published in 1603. We have here in Cassiopeia, of course, since he was using Tycho Brahe's catalog, we have the supernova of 1582. And way down here, we have a deep sky object. It's hard to see here. A deep sky object that's really in neighboring Perseus, the double cluster. And I found this very interesting because in the actual image of Perseus, the double cluster is not shown as a deep sky object, just as 2 stars. So he showed it as a deep sky object in Cassiopeia, but not in Perseus itself. Again, we have Cancer with Persephone. And we have Scorpius with M7 misplotted in the wrong place again. And we've introduced the large and small Magellanic clouds because now we have a chart of the southern skies based on observations by some Dutch navigators who then turned their information over to a Dutch cartographer who then plotted a bunch of new constellations in the southern sky. So these were among the first to be introduced, and this is where we get some of our southern constellations. Next atlas that was published was 1627 This is after the invention of the telescope, and so we begin to see the addition of some telescopic objects. We see a few more deep sky objects, we see things better plotted, we see more stars. This atlas was, however, not popular and really kind of ignored for one reason. Instead of Ptolemy's constellations, Julius Schiller decided to replace them all with Christian figures. So the zodiac became the 12 apostles. And above that in the northern sky, we had depictions of things from the New Testament. And in the southern sky, we had depictions of things from the Old Testament. So Argo Navis became the ark. Here we have, can anyone tell me what constellation that is? It's actually Andromeda. But this is what Julius Schiller did to Andromeda, and you can see Andromeda Galaxy right there.
What's it supposed to be?
This, yes, it was the sepulcher of Christ. This is now maybe somebody can guess this one. See here.
Oh, Taurus.
Taurus. This is St. Andrew. But it is Taurus. So here you have the Hyades and the Pleiades. And as promised, we have the Pleiades shown with 10 stars, more than shown on any atlas until, now this is 1627. More stars shown in the Pleiades than in any atlas until 1782. So 150 years later.
What's the K for?
I don't know. Somebody's going to guess this one. Cygnus, yes. You've got Cygnus, and this is Mary Magdalene with the cross. And you can compare it to Cygnus. Now, again, Bayer's atlas was geocentric, Schiller's was external, so things are mirror image. But I have to tell you, I think the artwork in this atlas is superior to the artwork in any other celestial atlas. I absolutely love the artwork. Scientifically, it was the best thing around. It was better than Bayer, but it wasn't popular because of its constellations. And Bayer's atlas went through many publications throughout the 1600s. A very few copies of Schiller's atlas have been found with no figures drawn on them. So here we have Andromeda again with the Andromeda Galaxy. And here we have in the south the large and small Magellanic Clouds. And I show it to you without any drawings because I think you'll agree when you see it with the constellation figures, they get lost. It's hard to even recognize that those are supposed to be the large and small Magellanic Clouds. They get lost in the artwork. Let's not forget about the moon when we're talking about celestial cartography. The first lunar atlas was published by a man named Johann Hevelius in Poland, and he published Uranography, which is a very famous work, and he showed the moon at many, many phases. Yes.
Do you have any idea what size telescopes these people were using?
Well, Hevelius, I think, eventually got up to about 5 inches, but I'm not sure what he used for the moon. And this is 1647. So I don't think we had Newtonians yet.
I have a 5-inch, so I'm curious. That's all.
They did a pretty good job. Hevelius is, he named things after features on the Earth. And that nomenclature stuck on very few things. It wasn't very popular. 4 years later, a man named Riccioli published a work with only 2 maps of the moon. One of them actually has labeled all the craters and everything. And he named the craters after famous people of science and astronomy, and even people like Schiller, who published that atlas with the Christian figures. His terminology was adopted. And although a few things from Hevelius carried over, and Hevelius is far more famous because of his complete atlas, it's Riccioli's nomenclature that carried down to us today. This is a chart from a work done with 30 charts in 1660. It's that one I told you that you buy a copy for $345,000. It has some interesting constellations, which we'll talk about in the next lecture if I'm invited back. But scientifically, it didn't add anything to the mix. It wasn't as good as anything that had been published before. But it's a very famous atlas, and the charts are highly prized because of their beauty, so we kind of can't ignore it. But Hevelius, the guy that did the lunar atlas, published a star atlas in 1687, 40 years after his moon atlas. Actually, it didn't come out until 1690 because he died in 1687 and his wife published it 3 years later, but it's dated 1687. And it is very similar to Bayer's atlas of 1603, but it has better, he did his own observations. He didn't rely on Tycho Brahe's, he did his own. And he did a pretty good job, but he couldn't see the southern sky. And so he relied on, this young astronomer named Edmund Halley, who had done a survey of the southern sky. And he relied on his observations of the southern sky. And that made his depictions of the southern sky far more accurate than anything that had been done before this. And here we see in Scorpius, M7 finally put back where it should be. And we see NGC, I think it's 6231 or 64, one of those. Yeah, which had been discovered by Edmund Halley. So we start seeing some of Halley's influence here. Here we have Andromeda. You'll notice that Andromeda is turned away from us, so we don't have to be exposed to her bare chest. But the real reason she's turned away from us is this is an external image, and so she has to be looked at from behind. But we have the Andromeda galaxy there. I guess I have to point this. Okay. So we have the Andromeda galaxy. And in Cancer, we have Persepi. And in Centaurus, we have Omega Centauri. Now, that was discovered by Edmund Halley. He's only credited with discovery of a handful of objects that are deep sky objects, but he just happened to bag this and M13, so he got the best globulars in both hemispheres. And of course, we have the large and small Magellanic Clouds. Our next jump is a substantial one. These atlases we've looked at in the 1600s are all very, very similar. They're mostly depictions of the constellations, a chart for each constellation. They're mostly on copper plate or steel plate, and they're engraved very nicely. And they're a big improvement over the 1500s, where all we had was woodcuts. Now we move into the 1700s with steel plates of a much larger size. And we have the atlas of John Flamsteed, the first astronomer royal. He didn't limit himself to charts of the constellations. He made charts of equal size, regardless of how many constellations showed up. This was published in 1729. He died in 1719. It took 10 years for his wife to publish the atlas after he died. It was in the works, but it took her a long time. He was a perfectionist and wouldn't publish his work. I think it was 1708, I'm guessing, Edmund Halley and Isaac Newton went to him and begged him to publish his catalog of all his, because he'd been cataloging stars for navigation purposes, and he refused to do it. So Edmund Halley stole a copy and had it published. And Flamsteed was so furious, he went and got almost all the copies and had them destroyed. And they've had a falling out and never were friends again. But thankfully, enough got saved that his atlas did get published. And it triples the number of stars in any previous atlas. And we can see that there's focus on equatorial coordinates for the first time. Every atlas had equatorial and ecliptical coordinates, but the ecliptical ruled up until this. This was the first atlas that really relied primarily on equatorial coordinates. So the ecliptical coordinates are still there, but the equatorial ones are the ones that matter. Now, we don't see any deep sky objects on this one, except possibly M31. You can make I'll make an argument for M31. And the reason for that is Flamsteed's focus was navigation. How do I help the England ships navigate? And the answer to that is with stars, not with deep sky objects. So here we see Andromeda Galaxy shown, and if you get a close look, it shows it with little dots instead of just a black sky around it. So I think that was his attempt to show it as a non-stellar object, but you have to kind of interpolate. If you didn't know it was non-stellar, it's not really clear. He was the first to show Persepi as individual stars. Again, you've got the telescope. So, by the way, Hevelius's atlas is 1687. Hevelius didn't trust the telescope and refused to use it for his observations. Here we have the Pleiades, but only 1, 2, 3, 4, 5, 6, 7, 8, 9 stars, one less than Julius Schiller's in 1627. So it still doesn't match what Schiller did. Flamsteed's atlas got republished in 1653 and 1681, but these were large charts and kind of unwieldy. And so pocket atlases began to appear, and everybody was copying Flamsteed. So it's even called, this French atlas is called the Atlas of Flamsteed, 2nd edition, but it's only about this big. And the charts, we'll go through and see some of the charts, but there was this French edition in 1776, the German edition in 1782, again, basically copying Flamsteed's charts, but showing more detail. We have another French edition in 1795. We have one by a German guy, Goldbach, in 1799. Then Bode it reissued his 1782 in 1805, and Goldbach reissued his in 1816. And then a guy in England published one in 1822, and they're all little copies of Flamsteed's atlas. So here's an example of one from the French 1776. And you can see some of the differences. Look at this area right here and compare it to this one from Bode's 1805. So as the years went by, more and more stars and deep sky objects got added. In Bode's, we have actually a chart that shows us different characteristics. So we're beginning to discern that these deep sky objects have different natures. They're not calling them open clusters and globular clusters and nebula and galaxies because they didn't know what they were, but they're showing them as a little difference of how they appear. He also included any supernovas and novas along with the year they occurred. Bode's Atlas of 1782, if you read my article from February of last year, and I talked about this atlas, is really what I consider to be the first deep sky atlas. It had about 70 deep sky objects, enough to kind of wet your whistle. And he included this separate chart showing a lot of these objects and describing them in the text. And so I think it's clear he was encouraging people to go out and look at these deep sky objects. We can't know if people did, but clearly I think this would qualify as the first deep sky atlas. Here we can see the Pleiades shown in far more detail than ever before. We have the Hyades in great detail. We have Persepe in great detail. Here we have Andromeda with M32. Here we have Sword of Orion and a drawing of the Orion Nebula. And lots of individual little drawings of different things, which if you read the text, you can figure out what they are, which Messier objects they equate to. He also had a chart for double stars, similarly described in text. I'm not a double star enthusiast, so I haven't tried to figure out what each of these actually represents. But let's just say if anybody's interested, I'd be happy to work with you and you can figure out what each of these is. And you can see that it basically shows comparative brightness of the stars and their angles at the time that he was making this list.
The one for 19, say Mizar?
Yes.
Mizar, and that's quite poor parallel.
Yeah.
Hertz Arl, art of Arl.
Yeah. This was an interesting one, that Goldbach German Atlas of 1799, in that this was the first complete atlas showing white stars on a black background. And for each chart, he showed it with constellations and coordinates drawn in and without. Now, if you look closely at this, you'll see some stars are underlined. These are double stars. And we see a lot of deep sky objects shown. These are the nebulas, the Messier objects. So they're beginning to show a lot more detail, but they kind of peak at about 100 or so objects. And they still have a lot of false objects, things that aren't really there.
Is that the Milky Way?
Yes, that's the Milky Way.
2 lines, underlines, and doubles, triple star.
I think a triple star, yes. Or at least what they thought was a triple star. Boda's Atlas, the guy who did that first deep sky atlas, he produced the real peak of the craft in 1801. Uranography, 1801. And this was a huge increase. The charts are very large. Certainly not something you could easily carry out and work with in the heavens. I mean, in the field. They were very similarly laid out to Flamsteed's, but they show far more stars. Instead of about 3,000 stars, we're up to about 17,000 stars. And in addition, he took all of Messier's objects and all of Herschel's 2,500 deep sky objects and several hundred of Herschel's double stars and plotted everything. So this is really the peak scientifically where we have combination of art and science. After this, it was all downhill. But you can compare, for example, look at this area above Andromeda. You can see there's far more stars on Boda's 1801 compared to Flamsteed's 1729. You can see that the charts are reasonably similar. Boda has more, he was the guy who boosted us to 109 constellations. He showed everything anybody could think of. And his atlas was really, as I said, the peak. It was everything. Here we see M31 with lots of other deep sky objects, and they're numbered 1, 3, 5, 5. The numbers refer to the nature of how those objects appear in a good telescope. You'll also see this symbol by some stars, and that was his recognition that those were double stars. So he included all of Herschel's 2,500 objects at that time, and Herschel's double stars, several hundred of those. Here we see the double cluster. And here we see in Coma Berenices, it's hard to really see from where you are, but there's lots of these little things that we now know are galaxies. They're all over. There's more than 100 just on this one portion of one chart. So he's really showing a lot scientifically. And here we have the southern Milky Way with lots and lots of deep sky objects shown. In 1822, a gentleman in England published an atlas, again, based on flam seeds. And here you can see it pales in comparison to Boda's. It's still a small chart, but our scientific content isn't as good as it was in 1801. This is more for popular stuff. And the first American publication of an atlas, very famous because Burritt's Atlas in 1835 was used in schools throughout America. But his atlas really only had 4 charts of the seasons and then 2 polar charts showing the polar constellations. And scientifically, it's very inferior to the stuff that Boda and others were putting out. Still, it at least gave students a chance to understand how the heavens were arranged, the constellations, and to see some stars. So when did our first modern atlas appear? After Boda's 1801, you saw the split where things with constellation figures were really designed really to just be popular, and things with scientific content got rid of the artwork. But they didn't really have as much knowledge of the heavens as we do today. The first modern atlas, and I know it's hard to see there, but it uses all the symbols that we're familiar with today for open clusters and globular clusters and planetary nebula and nebula and dark nebula. It really, all of this came together beautifully. Here we see the Andromeda Galaxy. In 1948, a guy named Anton Bekvar published this atlas. And that was news to me because I bought a Tyrian in 1986, thinking Tyrian had kind of invented this stuff. Well, Tyrian did it with a computer, and he was the first to really publish a great atlas using computer plotting. Bekvar did everything by hand, completely by hand. So today we have wonderful atlases. Here's just a sampling of an area in Virgo showing the Virgo cluster of galaxies. The scientific content is everything we could hope for. We really can't exhaust what's available on these charts with our telescopes. You can search for years and years and years before you found everything, and you're always trying to get the next greatest set of optics, right? But I'd say even though with everything we've gained, you have to admit something's lost. So here we have lots and lots of cluster of galaxies in Virgo, but we have the beautiful, charming artwork too. So let's review. Here we have 1482, a picture of a constellation, but no science. Here we have the first, this is Cancer also, from 1540 by Piccolomini. We have more accurate stars, or I should say we have accurate star positions, but we don't know where they are because there's no coordinate system. And then we have Gallucci's Atlas of 1588. We've got a coordinate system. We have those stars. We begin to introduce a few non-stellar objects, deep sky objects. We have that coordinate system to help us figure out where things are, but we're still relying on woodcuts. Then we move to Bayer's Atlas of 1603, where we've introduced metal plates, engraved metal plates, much better detail, observations by modern astronomers like Tycho Brahe. not really much more in the way of deep sky objects, because first off, the telescope hasn't been invented yet. 1687, now we have a telescope, but Hevelius really didn't rely on it. This is a better atlas than Bayer's, but only marginally. It does have much better plotting of the southern skies, much better. Then we have Flamsteed with the equatorial coordinates, much better charts, many more stars, no deep sky objects. And then we have 1801 by Boda with 17,000 stars, 2,500 deep sky objects, many double stars, and that kind of wraps things up for us. So I'm ready to take questions if you have any. Yes, sir.
What happened to 88? How did we get at 88?
Come to my next lecture.
Oh, I see. Good advertising.
Yes,
Pretty admission for that one.
you bet. Yes. What I've read says that because globes were popular and celestial globes use an external view, you're looking down from outside, that they just translated that into flat charts. So I don't think it was because of things like Newtonian reflectors. What you see is it goes back and forth in the 15 and 1600s, and then pretty much settles on a geocentric view of the heavens in the 1700s and beyond. There were many globes, yes. They not as well done and not as survived. The biggest globe done was for the King of France by a guy named Corneli, and he did one that was about 20 feet in diameter. And it hasn't survived, unfortunately, but he did one that's 42 inches in diameter. Some of those have survived. I've got one gore from that in my collection, and a complete set of smaller gores that were reduced because there's a company that will make you one that's only 33 inches if you're willing to spend about 10,000. They were willing to send me a set of their gores just to study. So I own a set of their gores, but I had to promise not to make them into a globe.
I also thought the reason for the reversal is that that's the way that God would see the constellations looking from outside the dome.
I don't know.
Sounds good.
Any other questions? Yes, sir.
Curious, how much was naval navigation dependent on multiple stars, or was it mostly just a few stars?
It's not something I'm very familiar with. I know that when I was in the Navy, we didn't rely on charts, we relied on catalogs. And there were many, many catalogs published, and the catalogs are distinct from the star charts. But it's interesting because I found discrepancies between what they try to interpret what the catalog means and what you then see on a star chart. For example, that NGC that was plotted on the Hevelius Atlas based on Edmund Halley's observations. In the catalogs, they say, we think this is such and such. But if you look at the chart, it's clear what was intended because Hevelius was in communication with Halley himself. Other questions? Now we'll get inside. All right.
Were these commercially successful, or were they more for just scientific?
I think most of them were commercially successful. I think you could say that Piccolomini's in 1540 was highly successful because there were 13 publications of it by different editors. Byers was published, I think, 10 times in the 1600s. Flamsteed's got published and then copied by everybody else. So there were a few that were not commercially successful. There's one that got that's dated 1751 and didn't appear until 1784. because it just got lost or put away, and then somebody found the charts and decided to try and sell a few. And so that it really wasn't ever a commercial success. Clearly Flamsteed's wife and Hevelius's wife were looking for them to be commercial successes because they published them posthumously. And I'm sure that was partly to make some money.
There any online questions?
There are no online, oh, and hold on a second, one just literally came in. When did the modern catalog begin to use heliocentric coordinates, include right angle and parallax data? That's from Brian Kelly.
I believe if you start seeing the Hipparchus data show up in Uranometria 2000.
Yeah.
That's the first I remember.
Well, the first parallax would have been 1836 or something like that.
But not shown on a star chart necessarily.
That when they first knew.
Yeah.
Yep. So do you have a favorite, and can I give you two dimensions from an artistic perspective and then from a scientific perspective?
My favorite from an artistic perspective, my favorite chart of all the ones I own is the St. Andrew Taurus from the Christian Atlas, which is funny because I'm Jewish. But cool.
That's okay.
But the scientifically, there's a chart I find absolutely fascinating, which I'll talk about in my other lecture, where a constellation called Hevelius's Little Telescope is shown in or near Orion, pointing at a star that's labeled Herschel. Well, that's what they called Uranus back then, but it doesn't equate to where it was discovered by Herschel. And I had to go back and calculate what year that's plotted for. And it's plotted for 1690 because Flamsteed spotted it in 1690 and recorded it, but he didn't know he discovered Uranus.
Interesting. Very cool.
Yeah.
Thank you.
So these cartographers, their data is from observation and not from photography. Photography was invented in, I guess, the early 1700s.
No, photography came in
1630.
No, photography came in 1830s or 40s. 18. Yeah, so this is all before photography. And there were photographic atlases in the late 1800s. That's the first photographic atlases.
But how did they observe over time, hundreds of objects in the sky and plot it? I don't understand how they could.
Well, what they usually did is they pointed a telescope and let the sky go by. And as it went by, they'd record, okay, that star appeared here, and they would record it. So they'd end up with a catalog. And that's why equatorial coordinates became so important in the 1700s. Before that, they were using elliptical coordinates, and boy, that's tough. But they would literally get an equatorial aligned telescope to point. They'd know where it was pointing, and they would just watch the sky go by. And when a star passed it, they'd say, "Okay, it's at this position." Yes.
Does a modern nuclear sub even carry a sextant anymore?
Well, modern for me was 1977. So today, I don't know. I would guess yes as a fallback. We used basically what you'd call GPS, but it wasn't called GPS back then. It was satellite navigation. Yes.
When did epochs come in?
Oh, very early. And we can determine the epochs for all these star charts. For example, there's an atlas published in 1741 that used epoch 1730. The atlas of 1801 used epoch 1800. The atlas of Beckvar's atlas of 1948 used 1950 coordinates. the atlas, let's see, I don't know them all off the top of my head, but I've got all that recorded.
In
I
other
have
words,
that
it's
data.
relatively early. That's what
Yes,
you're saying.
yes, they started using epics even with, I think Albert Dürer interpolated Ptolemy's data and used an epic.
Yeah.
In the early 1500s.
So I have a correction from the internet. Let me see if I can read this. When did the modern catalogs begin to use proper heliocentric coordinates and include proper motion and parallax data? We originally wrote RA. Does that change your answer at all?
No.
Okay. Okay. Sorry, Ryan.
You said chart. Did you mean a piece of an atlas that's been dismembered?
Most of these atlases you can buy individual charts from because dealers have broken them up to make money.
Yes, I know somebody that bought some pages from Atlas. What's your opinion about that?
I say let's never do it again.
Yes.
However, people are greedy and they want money, and it's easier to sell individual charts and get more money than for a simple atlas.
What would they go for, like one page?
You can buy a chart from the 1822 atlas for $150. You can buy, I've never seen an individual chart from the Piccolomini atlas of 1540, even though it was published in 1548. I've got an atlas, 1548, in 1552, and a bunch more times in the 1500s. I've never seen an individual chart. I've never seen an individual chart from a Gallucci atlas of 1588, but I've seen hundreds from the Bayer atlases, 1603 and later. And I eventually acquired some from the LVAAS atlas of 1687. And since then, I literally was buying every one I could find because they were just so rare. But since then, I've seen a great many. And so obviously more are out there. And then the 1627 Schiller atlas, I've seen many of those for sale. But you can, some of these are they're not that popular. So somebody could break up one atlas and there could be charts on the market for years and years and years.
Is there any kind of inventory of how many are left? Tech?
Oh, not that I know of.
Yeah. Another question from the internet. What is the collector's market like for these charts and artifacts? Obviously, you've been able to snap them up, right?
I've bought mainly from reputable dealers. I have purchased a few things on eBay, but mainly from reputable dealers. You're going to pay most of the time it's negotiable. You can negotiate things down, but I've developed a fairly good network of reliable dealers. For one thing, back when I was more actively collecting, now I'm kind of happy with my collection and I only add things that really, really look special. There was an antique book show in New York City held at the Armory on 67th Street that had dealers from all over the world, 200 dealers. And probably a quarter of them had celestial material. And so I would begin to build a network that way.
Cool. Questions? Well, when you buy a new atlas, does anyone tell you are you going to sell one of your old ones now? Or is that only telescopes?
Yes, sir.
Art. How far back is it? Art.
I'm not sure what you're asking. Are you saying how early did they start making star charts? Yes, but there are a few known manuscript star charts before the time of printing. They're extremely rare. I've never seen one for sale. They're probably all locked away in major collections. But the printed stuff allowed them to make many, many copies. And so with the advent of printing, we see maps of all kinds. We start to see atlases of the world. And that's a fast, if you're interested in cartography in general, not just celestial, there's maps, there's people who collect nothing but maps of the Philippines. You know, it's just, you can study any area of the world and go back usually hundreds of years. Not so much in the Western hemisphere, you're kind of limited. They start obviously in the 1500s. Yes, sir.
So just as a point of trivia, is there any information about approximately when the original constellation was and astrology names that we're familiar with, when that originally started?
It goes back quite a ways. I think you can look at stuff around the Fertile Crescent. There's a lot of information about some of the early constellations. Ptolemy in the 2nd century AD clearly relied on earlier sources that are lost to us. He referenced them,
Okay.
and they're lost to us. How we ended up with 48 from him isn't clear. We don't know the real origin of many of those constellations. I've read lots about how far some of them go back. I don't have that all up in here in my head, but we can't trace them all back. We can't tell where they all came from.
I was just wondering if there's anything from the Egyptians or the Turks or anything like that may have filtered through, or
Not so much the
No.
Turks, although we owe a tremendous debt to the Persians, the Arabs. My son, who speaks Arabic fluently, he was an Arabic linguist in
Thank you.
the army. Told me, I mentioned to him about Altair once, and he said, "Altair, you mean Altair?" And I said, "What is that?" And he says, "It's Arabic for eye of the eagle." And when you think about it, it's the bright star in Aquila, right? So
Okay.
Aquila. So, we're talking about the Arab contribution is phenomenal. And in fact, the double cluster was plotted by Al-Sufi in the 9th century, along with Andromeda. So there are things that Ptolemy didn't know about that were clearly understood by the Arab community.
I was wondering, is there any of these charts made by Benjamin Banneker? Because I know he did calculations to solve big brick house. I know he had commented various,
I suppose you could Google it and see what comes up, but I'm not
you've
familiar
never
with
ran
this. I'm not familiar with anything by him. A lot of times it's interesting because the astronomers weren't the cartographers. The Doppelmayr Atlas of 1741, Doppelmayr couldn't create a chart to save his life, but he worked with somebody he worked with the Hohmann publishers, and they published the atlas that he basically designed. So he had somebody else do the charts, whereas with Albert Dürer, he did his own. He was an artist. But in a lot of cases, you'll see someone like Bayer, he didn't engrave his own plates. Riccioli, who did that wonderful moon chart, did not engrave his own plates. So they were working in collaboration with the artists to produce the end product.
I just a little check about the Schiller maps and the interpretation of the Northern Cross of Cygnus was Helen, the mother of Constantine, who brought the Cross of
Oh, yeah?
back here.
Okay, thank you.
Any other questions?
No, but this has been great.
If not, let's thank.
Thank you so much.
You're welcome.
Obviously,
Obviously, that was really popular. So many good questions. Thanks, everybody, for your questions. And now it's time to go to our raffle. So we hope you bought your ticket. And thank you, everyone on YouTube, for attending our meeting. We're sorry you can't participate in the raffle, so join us next month here at the Radnor Community Building. Oops.
Okay, winning ticket 378 258.
Is that 378258?
378 258. There you go. Okay.
Right.
From the table. Yeah.
Wow, there's a lot of tickets in here. All right. 378233. Three, 7, 8, 2, 3, 3. Okay, we have a winner. Go and take something from the table. Three, 7, 8, 2, 2, 4. 224? 224 anywhere?
I
Anyone?
think I must have in your. Yeah, I got it.
All right, Dave Misty is the winner. I now have 378 279. Thanks. Get something from the Dave. 279, anybody? Got it. All right. Sylvia's won something from the raffle table. Let's go to the table and support.
It's great. But 13.
378 197. Congratulations. Pick something from the table.
Make sure you still have things at the table.
I feel a lot. 378 268. 268, anyone? 268? Ah. One
Yeah.
Ken, are you out of prizes or should we? Couple more? Okay.
He had in his lieutenant's box that I think he says to go home, you can put it out, so.
378 259. 59, anyone? Somebody has it. Going one. Carl has it.
Do it again. I already got something.
Okay, all right. 378 275. Me again. Pass it on. Thank you. Three, 7, 8, 3, 1, 0. Mitch Berger has won a raffle prize. How many more, Ken? 2 more? 378 213.
Yeah, right here.
All right, John has won a raffle.
Cool.
378-211. Okay. Demetrius has won again, or Yoko's won again. Okay, thank you. Will be our last one. 378-283.
Peanuts, sometimes shells.
283. Again?
We can't get them.
You're gonna take it, okay. All right, well, thank you everyone for coming. Please join us at the Valley Forge Star Party later this month. And we'll see you next month. You're in the Rather community building.
Thank you.
I did say goodbye to the YouTube people, but they were still there, right?
Yeah. So.
We just